We're going to look at math concepts in this section that are going to be very important that you know to be able to proceed with some of the physics concepts that we will be doing. If at any time you are struggling with any of these basic concepts, we need to get together, review these, so the math will not be the problem when you get to the physics. So to review, we're going to look at scientific notation. So scientific notation, we're looking at numbers written in the form of m times 10 to the n, or some exponent. Remember that m has to be a number that is between 1 and 9, and they're whole numbers, as well as the n value, the exponent, also has to be a whole number. So for example, you would have 1 times 10 to the 4th. Just a little hint, because we will be doing a lot of this online, control period will give you that exponent feature. And then you would hit it again to get back to the normal font. Or you can also write it as 10 to the 1 times 10 to the, and the caret, which is above the 6 to the 4. So in scientific notation, if we look at these values, 250,000 miles, we would move the understood decimal over 1, 2, 3, 4, 5 times, and that would give us 2.5 times 10 to the 5th. For B, we would move our decimal over 1, 2, 3 times, so that would give us 3 times 10 to the negative third. When you have numbers that are less than 1, you're going to have negative exponents. If we look at this number, we would move our decimal 1, 2, 3 times. So we would get 5.2, and we would need to keep these zeros because if they're written in this, that means they're important or significant figures. So we would write 5.200 times 10 to the negative third. When we look at this number, we already have one number and a decimal. So we would just do 2.0500, and it would actually be times 10 to the 0 because that means 1. When we're looking at significant figures, remember these are the figures in a number that we have measured out or that are specific to whatever measurement that we were talking about. So to determine the number of significant figures in a number, we're going to remember the Pacific Atlantic rule. So we have the Pacific Ocean and the Atlantic Ocean. So if we have a number such as 1002.00, there is a decimal present. So we'll start on the Pacific side and count everything starting with the first non-zero and on. So we would have 1, 2, 3, 4, 5, 6 significant figures. This one, the decimal is absent. So we're going to start on the Atlantic side, come to the first non-zero, and begin counting that way. So we would have 2 significant figures. If we look at this number, decimal is present, so we would start on the Pacific side, come to the first non-zero, and we would have 2 on this number as well. So if we look at these examples, the first one, how many significant figures? The decimal is absent, so we would start on the Atlantic side, come to the first non-zero, and we have 2. Decimal is present, come to the Pacific side, first non-zero, count everything this way, so we have 3. Decimal present, come to the first non-zero, and we have 1. Decimal present, come to the first non-zero, and so we have 4. Decimal is absent, so we come to the Atlantic side, go to the first non-zero, and this one would have 1. Next, we need to look at units. So we have the SI system, which is the International System of Units, the unit system that's used throughout the world in science. We have what are called base units. So this is when we're just looking at one quantity, and derived units when we're combining 2 base units together, such as miles per hour. The SI units, or different quantities, these are things that we learned in chemistry. You will need to make sure you know these. I love to put these questions on the test. For example, what is the SI unit for time? You would tell me second. What is the SI unit for length? You would tell me meter. So make sure that you're familiar with these. Not necessarily the currents or the intensity, but from amount up, make sure you're familiar. So the units in solving problems. First of all, looking at conversion or dimensional analysis. So in your book, or I will provide you with your conversion chart again, meters to kilometers and meters to centimeters. We're going to be looking at what are the equalities or the ratio between 2 units. So for example, $1 is how many quarters? So 4. 1 foot is how many inches? 12. But if we have 7 quarters, how many dollars would that be? So we would have $1.75. Here is your prefix chart, and again, I will provide that to you, and I will also have one linked on the Google Classroom. So for this example problem, we're going to look at converting meters to feet. And again, this conversion should be a familiar process. So we've got the tallest waterfall is 979 meters. Now, if we know our conversion straight from meters to feet, we could have a one-step problem. But let's say that we don't. So we're going to do meters on bottom, and let's do centimeters on top. And forgive my writing on this tablet. So in 1 meter, we have 100 centimeters. And then we can go centimeters to inches. 1 inch is 2.54 centimeters. And if you don't know that conversion, you might want to write that on your chart. 1 inch equals 2.54 centimeters. Then we can go inches to feet. So 1 foot is 12 inches. Then it's a matter of solving. And remember that we multiply all the non-1 numbers on the top, and then we're going to divide by the numbers on the bottom. So if I take 979 times 100 divided by 2.54 divided by 12, I get 3,211.94 feet for my answer. On this problem, we're going to convert 65 miles per hour to meters per second. So I'm going to start over here just to give myself a little bit more room. So 65 miles per hour So we're going to pick miles to start with. So we'll put miles on bottom because it's on top. And then we could go miles to feet. In 1 mile, there's 5,280 feet. And if you're not familiar with that, write that down. So 1 mile equals 5,280 feet. Then we're going to take the feet to inches. So 1 foot, because feet were on top, they have to go on bottom. So 12 inches on top. Inches on top have to go on bottom to centimeters. So in the last problem we did 1 inch is 2.54 centimeters. And then we can go centimeters to meters. So 1 meter is 100 centimeters. So we have the top of the problem taken care of, but now we have to get hours to seconds. So at the beginning we had hours on bottom. So now hours goes on top. And we can put seconds on bottom. So in 1 hour, there are 3,600 seconds. And now we're ready to solve. So as we calculate this, we're going to have 65 times 5,280 times 12 times 2.54. And then we have ones. So now we're ready for the bottom. And on the bottom we have, so we'll divide by 100 and then divide by 3,600. So for an answer, I got 29.057, so I'll say 06, and that's meters per second.